This is a previous IIT-JEE question basing on photoelectric effect, Einstein's photoelectric equation. A question says, a photoelectric surface is illuminated successively by monochromatic light of wavelengths lambda and lambda by 2. Maximum kinetic energy emitted in the second case is 3 times of the first case. Then what is the work function of the metal surface? First of all, according to Einstein's photoelectric equation, energy of the photon incident on a metal surface is first used to release the electron from the metal surface, called work function. The remaining energy of the photon is given to electron so that it moves with a certain kinetic energy. Energy can be written like h nu, that is hc by lambda. Work function is h nu naught, that is hc by lambda naught, plus kinetic energy. So hc of 1 by lambda by 1 minus lambda naught equal to kinetic energy. In first case, this value is lambda. In second case, the incident wavelength has a lambda of lambda by 2, has a wavelength of lambda by 2. There are two cases. So writing the two cases into equation, hc of 1 by lambda minus 1 by lambda naught by hc of 1 by wavelength is lambda by 2, threshold wavelength remains same, equal to kinetic energy in the second case is 1 by 3 times of, that's what is given for you. Kinetic energy in the second case is 3 times of the first case. So Ke1, if it is Ke, this I have to write it like 3 times of Ke. So Ke's can be cancelled, Hc's can be cancelled. We can further simplify this equation as 1 by lambda by 1 by minus 1 by lambda naught by, this 2 will come to the numerator, 2 by lambda minus 1 by lambda naught is the ratio of 1:3. Let's take the LCM in the numerator, lambda naught minus lambda in the numerator, again lambda naught, then 2 lambda naught minus lambda, right? I have just taken LCM of the numerator terms as well as denominator terms, is in the ratio of 1:3. Yeah, let us simplify this further. Lambda naughts can be cancelled. Lambda naught minus lambda by 2 lambda naught minus lambda is 1 by 3. Let's cross multiply them. 3 lambda naught minus 3 lambda equal to 2 lambda naught minus lambda. Get this 2 lambda naught to other side, it becomes minus. This to the other side, it becomes plus 3 lambda minus lambda. So lambda naught equal to 3 lambda. That's the threshold wavelength. Now we want work function. Work function is hc by lambda naught, that is hc by, in the place of lambda naught I can write 3 lambda. So that will be the answer for that problem. Even the next problem is also relevant to that. Look at the next problem. It was in IIT-JEE 2014. When the energy of the incident radiation is increased by 20%, kinetic energy of the photoelectron emitted of the metal increased from 0.5 to 0.8. First of all, according to Einstein's photoelectric equation, energy of the photon is used in 2 steps. First, to release the electron from the metal surface, called work function, and then kinetic energy. So when energy is increased by 20%, so what's the equation we can write here is, energy in the first case is E, in the second case is E plus 20% of E. Metal work function remains the same because work function depends on the frequency but not on the energy, right? The metal is same, the work function remains the same. Kinetic energy in the first case is 0.5 electron volts. The second case, kinetic energy is, as it is given, 0.8 electron volts. Let's simplify this. E by E, 20% means 0.2 times of E. E is work function plus 0.5 by work function plus 0.8. So E can be cancelled. 1 by 1 plus 0.2. 1.2 equal to work function plus 0.5 by work function plus 0.8. Cross multiply them. Work function plus 0.8 equal to 1.2 times of work function plus 1.2 into 0.5 equal to 0.6. So 0.2 times of work function, when you take this to the other side, get this to this side. 0.8 minus 0.6. So 0.2 of work function is 0.2. Then work function equal to 1 electron volts. So the answer for this problem is 1 electron volts. So in solving both these equations, we are depending on only one simple concept, that Einstein photoelectric equation says that the energy of a photon, incident photon, is used when it strikes the metal surface in two steps. First, to release the electron from the metal surface, called work function, and when the photon has an excess energy after doing the work function job, that is given as kinetic energy to the electron, therefore electron can move with a certain velocity. That's how we solve both these problems. Thank you for watching.